Hi, my name is Shvetali Thatte, and today we will be looking at DNA damage control in cells. Over time, DNA in cells is damaged due to mutations. Mutations are changes in the nucleotide sequence that result in a different protein being produced. While not all mutations are detrimental, some can be. One of the ways that a cell regulates these mutations is through the p53 pathway. p53 is a protein that can act as an inhibitor of the cell cycle, preventing cell growth, or an activator of the apoptotic pathway, inducing cell death. There are three different pathways that a cell can take regarding the p53 pathway. Let's take a look at them. The first one is when there's no DNA damage. When there's no DNA damage, the MDM2 protein ubiquitinates the p53 protein, leading to its degradation. The reason MDM2 ubiquitinates p53 is because when there's no DNA damage, there's no reason for the cell to stop growing or to have its apoptosis be induced. Therefore, the MDM2 degrades the p53 because it is unnecessary. The next pathway that can be taken is when there's some DNA damage, which is very minimal. In this case, proteins ATM and CHK2 phosphorylate p53, activating it. The phosphorylated p53 protein upregulates its own transcription and activates p21, p27, pCNA, and GADD45. pCNA and GADD45 repair the DNA while it is in the S phase, and p21 and p27 inhibit the cell cycle, keeping the cell from growing while the DNA is being repaired. The last pathway that can be taken is when there's a lot of DNA damage, and this is when the DNA damage is not repairable. In this case, the cell sends a signal to p53, and p53 upregulates the transcription of BCL-X and BID. p53 is a transcription factor of these proteins. Therefore, it binds to the DNA and is able to upregulate the transcription of both of these proteins. Both of these proteins activate cytochrome C, which in turn activates the caspase cascade. The caspase cascade is essentially a series of cleavages that happen on proteins, leading to the induction of apoptosis. As you can see, the p53 pathway is critical to maintaining damage control. It makes sure that cells can repair their DNA by inhibiting their growth, and if the damage is not repairable, it makes sure to kill the cell in order to make new space for cells to grow. Without the p53 pathway, cells would continue to grow with incorrect protein and DNA mutations in it, leading to the uncontrolled growth of cells, also known as cancer.